What's up, Accelerated Chemistry students? This is Mr. Spurk, and this is your Chapter 11, Section 2, Notes all over types of chemical reactions. So chemistry and you, let's talk about what happens when you burn a candle. When you burn a candle, a chemical reaction is actually taking place, and that is called combustion. So let's get right into it, classifying different types of reactions. By classifying chemical reactions, you can more easily predict what products are likely to form. There are 5 general types of reactions, and they include combination reaction, decomposition, single replacement, double replacement, and combustion. Not all chemical reactions fit uniquely into one category. Occasionally, a reaction may fit well into 2 categories. Patterns of chemical behavior will become apparent and allow you to predict the products of reactions. So let's start with combination reactions, also known as synthesis reactions. A combination reaction is a chemical change in which 2 or more substances react to form a single new substance. For example, let's look at magnesium plus oxygen yields MgO. We can see that the Mg and the oxygen have combined to form magnesium oxide, which is a solid. The product is a single substance or a compound, and our little skeletal equation, or just kind of a general equation that you can use to try and remember these, is A plus B yields AB. When a group A metal and a nonmetal react, when a group A metal and a nonmetal react, the product is a binary ionic compound. So when we have potassium reacting with chlorine, we get KCl, a binary ionic compound. When 2 nonmetals react in a combustion reaction, more than one product is often possible. So we could have sulfur plus O2 yielding SO2. Those 2's should be subscripts. When I uploaded these, the formatting must have shifted a little bit. But we have sulfur plus oxygen yielding SO2, which is sulfur dioxide. But other times when we add sulfur and oxygen, we could get sulfur trioxide, SO3. More than one product may also result from the combination of a transition metal and a nonmetal. Think about how we have copper 1 and copper 2, we have iron 2 and iron 3, and many others. So now the second type is decomposition reactions. And these are just the opposite of our combination reactions. So here we have 2HGO with a little bit of heat as the catalyst yields Hg and O2, 2 separate compounds. A decomposition reaction is a chemical change in which a single compound breaks down into 2 or more simpler products. There's only one reactant, and there's 2 or more products. Most decomposition reactions require energy in the form of heat, light, or electricity. So a little general reaction here is AB yields A plus B, the reverse of our combination reaction. So let's talk about writing equations for combination and decomposition reactions. So if we look at the combination of copper and silver, remember this is one of those ones where we could see multiple products because we know that we have copper 1 and copper 2. So let's start with copper 2. We have Cu, which is a solid, and we're adding that to sulfur, which is also a solid. And if this is copper 2, then we know that this is going to be Cus because our charges are going to balance. Now, if we look at copper 1, we're going to have Cu plus S yielding Cu2S. Now remember, we need to think about balancing our equations. So if we look at these coppers, we can see that we have 2 on the right and only 1 on the left. So we're going to add a 2 in front of the copper over here. And now we have a balanced equation. If we look at the next part, the decomposition of water. So decomposition, remember we start with one compound and we're breaking it apart. So we have H2O yielding H2 and O2. Now again, we need to think about balancing this equation here. We have 2 oxygens on the right, so we're going to add our 2 over here, and now we have 2 on the left. But now we have 4 oxygens on the left, so let's get 4 oxygens on the right by adding the 2 in front of H2. The next type is single replacement reactions, and an example of this is dropping a small piece of potassium into a beaker of water. It creates a vigorous reaction. It actually ignites and we can see flames. So that equation is 2 potassiums plus 2 waters yields 2 KOH plus H2 gas. So if you drop a piece of zinc into a solution of copper nitrate, this reaction is going to occur. We have zinc plus copper nitrate yielding copper plus zinc nitrate. So you can kind of see that the two have swapped places. So this is a single replacement reaction, and it's one in which one element replaces a second element in a compound. You can identify a single replacement reaction by noting that both the reactants and the products consist of an element and a compound. And our little general reaction here is A plus B yields B plus C plus AC, where we see that A and B have swapped places. It's a single replacement reaction. So let's look at writing an equation for a single replacement reaction. We have Cl2 plus NaBr, and Cl2 is more reactive than bromine. So chlorine is going to replace bromine. So we are going to get Br is going to get kicked out, and we know that Br is a diatomic element, so it's Br2 plus NaCl. And I'm sorry, this should be AQ. And so now we need to think about balancing this equation as well. So we have 2 chlorines on the left, so we need 2 chlorines on the right. And we have 1 sodium on the left, but 2 on the right. So let's add our 2 here, which gives us 2 bromines on the left and now 2 bromines on the right. So this is our balanced equation. So single replacement reactions, whether one metal will displace another metal from a compound, depends upon the relative reactivities of the two metals. Iron will displace copper from a copper compound in solution, but iron does not similarly displace zinc or calcium. The activity series, which is over here pictured on the right, the activity series of metals lists metals in order of decreasing activity. So a reactive metal will replace any metal that's listed below it. So if we look, magnesium will replace lead, but lead will not replace magnesium. A halogen can also replace another halogen from a compound, which we just saw 2 slides ago with chlorine replacing bromine. The activity of halogens decreases as you go down group 7A on the periodic table. So here we have bromine plus NaI yields NaBr plus I2. So we see that bromine is higher on the periodic table than iodine, so bromine will replace iodine. And if we look here, bromine plus NaCl, this is actually no reaction because bromine is less reactive, it's below chlorine, so it will not replace chlorine. Another type is our double replacement reactions, and this happens when we're mixing aqueous solutions of potassium iodide and lead 2 nitrate, for example, and that results in a chemical reaction in which a yellow precipitate, which just means a solid, of lead to iodide is formed. So our general reaction for these guys is AB plus CD yields CB plus AD. So what I like to do is I think about them as AB plus CD, and I swap A and C and leave B and D where they are. So as we get into more equations, you'll see how this applies. So if we look at 2Ki plus lead nitrate yielding lead iodide plus potassium nitrate, we can see, looking from left to right, that the potassium and the leads have traded places. Because on the left side we had Ki, and on the right side we have PbI2. And on the left side we had PbNO3, and on the right side we have KNO3. So potassium and lead have swapped places. This is a double replacement reaction. So a double replacement reaction is one in which is a chemical change involving an exchange of positive ions between two compounds. Generally, this takes place in aqueous solution and often produces a precipitate, a gas, or a molecular compound. For a double replacement reaction to occur, one of the following is usually true. The first one is that one of the products is only slightly soluble and precipitates from solution. The second one is that one of the products is a gas. Or the last one product is a molecular compound. So let's write an equation for a double replacement reaction. A precipitate of barium carbonate is formed when aqueous solutions of barium chloride react with potassium carbonate. Write the balanced equation. So if we look at these, we know that K and Ba are going to switch for us because they are in our A and C spot. Also, they're both the positive cation, so they're going to swap places. And we know from our problem up top that barium carbonate is a precipitate that is formed. So let's write these out. We're going to swap potassium and barium. So BaCO3, because barium is a 2 plus and carbonate is a 2 minus. And these are, this is a solid because it tells us that it's a precipitate. And then we have KCl, which is going to be aqueous. So now again, we need to make sure that we have a balanced equation. So to balance this guy out, we're going to put a 2 in front of KCl. And now we are balanced out across the equation. The last type is combustion reactions. These might be the most fun reactions to see. So the skeleton little general equation for this is CXHY, which just means some subscripts, plus O2 yields CO2 plus H2O. And this guy, CXHY, is what we call a hydrocarbon. The flames of a campfire, candle, or gas grill are evidence that a combustion reaction is taking place. A combustion reaction is a chemical change in which an element or a compound reacts with oxygen, often producing energy in the form of heat and light. This type of reaction always involves oxygen as a reactant. And often, the other reactant is a hydrocarbon, which is a compound composed of hydrogen and carbon. Complete combustion of a hydrocarbon produces carbon dioxide and water. But if the supply of oxygen is limited during a reaction, the combustion will not be complete. Elemental carbon, or soot, and toxic carbon monoxide gas may be additional products. These reactions release a large amount of energy as heat. The complete combustion of gasoline is this equation right here. So we have the equation for gasoline, which is C8H18, reacting with O2 because we have our hydrocarbon. We have our hydrocarbon right here reacting with oxygen, yielding carbon dioxide and water. So really one of the main things we're going to see change here is a change in this guy, because we're always going to see in a combustion reaction O2 as the other reactant and CO2 and H2O as the products. But there are other types of combustion reactions, and these are of metals or nonmetals. So these reactions between oxygen and some elements other than carbon are also examples of these combustion reactions. We can have magnesium burn in oxygen, which produces MgO, and sulfur burn in oxygen, which produces SO2. An alcohol lamp often uses ethanol as its fuel. So let's write the balance equation for the combustion of ethanol. So if we look at ethanol, we have a hydrocarbon. So we are going to combine this with oxygen, and that's going to react to give us CO2 and H2O. So again, when we write our equations out, the last step is to always balance them. So let's balance out our carbons. We have 2 on the left and only 1 on the right. So we're going to add a 2 in here. And we have 6 hydrogens on the left and only 2 on the right. So let's add our 3 here. So now our carbons and our hydrogens are balanced out. So now we need to look at our oxygens. We have 1 oxygen in the equation for gasoline and 2 right here. And on the right side, we have 4 oxygens from carbon dioxide and 3 oxygens from water. So on the right side, we have a total of 7 oxygens, and we have 3 on the left-hand side. So we can balance that out by putting a 3 in front of O2, because that will give us 6 right here and 1 from there. So now we have 7 and 7 on each side. So let's recap. A combination reaction is 2 or more reactants combining to form a single product. Decomposition is a single compound. A single compound is a reactant. 2 or more substances are the products. Single replacement reactions, an element and a compound are the reactants. Double replacement reaction, 2 ionic compounds are the reactants, and 2 new compounds are the products. And the last one, combustion reaction, and that is when reactants are oxygen and usually a hydrocarbon, and the products of most combustion reactions are carbon dioxide and water. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry 2000 edition of the textbook, the resources CD, and pearsonchemistry.com. Have a good night, guys.